Now we're going to get into the exact definitions that we're interested in answering the question. First, f has a stationary point when x has a value of a if the derivative at that point is 0. So whatever our x value is at that point, if the first derivative is 0. The important thing to remember about a derivative is since it's the slope of a tangent line, a 0 slope would be a horizontal tangent line. So for us, I like the analogy that you could rest a line completely flat and balance it. So our first line could rest right here over an x value of -4, but right here we have a height of 3. So we're going to go ahead and list that first coordinate. Remember, a coordinate is an x and a y value as -4, 3. Based on what we just saw, you may feel that you can figure out the next horizontal tangent lines, but actually it's a little deceiving because people don't really notice. I didn't do the best job of drawing it. But right here where x is -2, because the graph is flat at that point, we technically have a horizontal tangent line, and it's hard to see, but our height is 0. So we're going to list -2, 0 as our next tangent line. Again, 0 slope tangent line. Again, the next stationary point that people don't always catch is way down here. Because even though I talked about being able to like maybe rest a ruler and have it balance our horizontal tangent line, slope of 0, keep in mind that down below it's not resting there, or if we could flip the graph over, we still would have a rise up 0 but run over to the right. So we need to actually list the point where it's hard to see, but where x was 0 and we had a height of -1. And then people tend to think that they can draw a tangent line over here, but actually that's not true, because what happens, it's such a sharp point that you can touch the graph once and be at many different angles, not just 0. So this point where x is +2 is actually not a stationary point. It turns out it's going to be a singular point. So let's talk about that. A function at a value of a is singular if the derivative is undefined. Now that one's tricky for us because we haven't really talked about undefined derivatives, so we're going to look at it two different ways. Graphically, we're going to say this is where the graph has a sharp corner or point, but since later we won't see the visual representation of our function, we also should know that a singular point occurs where you have 0 in the denominator of a fraction. Remember, any fraction with a 0 denominator, say that weird, is an undefined fraction. So this point up here that we just talked about is our only coordinate of a singular point. Now, the next thing that we're asked is to find critical points at A. And so the definition of a critical point is if that point value A is a stationary or a singular point. So when I'm asked the coordinates of the critical points, basically what I need to do is come take these answers, because these are all of the stationary and singular points for this problem. Quick note, when I did my web assign problem and I was checking your homework, I got it wrong. And I'm like, how am I getting this wrong? I know the answers. But the question says to answer the critical points in order of the x values. So we need to focus on all of the different x values and be sure to list these four ordered pairs in x order, which in our case, that's exactly what happens. An x value of -4 is the smallest x, then a -2 is our next smallest, followed by an x of 0 and an x of 2. But generally, we don't tend to find them in order, but we need to focus that way for our answers.